Welcome back to Mrs. Law's class. In this video, we're going to take a look at a special hyperbola called the rectangular hyperbola. Now this occurs when A is equal to B, and the asymptotes are then going to be perpendicular to each other because A does equal B. So the equation will look like this: x squared over A squared minus y squared over A squared equals to 1. So since my slope of my asymptote is equal to plus or minus b over a, and b actually equals a, then we actually have plus or minus a over a, which is plus or minus 1. So our asymptotes go through our center like before. And then the special feature is that they are perpendicular to each other. So whether they open left and right or up and down, we get the same thing happening, which is the asymptotes crossing each other at 90 degrees. And when the equation opens up and down, we get the equation x squared minus y squared equals negative a squared, or we can also have y squared minus x squared equals positive a squared. All right, let's take a look at an example. So here I have y squared minus x squared equals 25. And let's also find the length of the transverse and the conjugate axis. And let's find also the equation of the asymptote. Now, because this is a rectangular hyperbola, and we can see that it is because y squared minus x squared is equal to 25, and it's only one number. There's no coefficients in front of y squared or x squared. So we can say that the transverse axis is equal to the conjugate axis. And we find that by the square root of 25 times 2. So it's going to be 5 times 2, which equals 10. And then the slope of the asymptote is equal to plus or minus 1. And let's graph this first. So we have our center at 0, 0. And we're going to draw a box so we know that it's 5 in every direction. So draw in your asymptotes first. And then because it's y squared is a leading term, then we have our hyperbola opening up and down. Okay, and then the equation of the asymptote is going to be y is equal to plus or minus, and we can include the 1 if you like, but we can just put plus or minus x. And in this case, it goes through 0, 0 because we don't have any numbers adding to y or x. Lastly, I want to show you a special case rectangular hyperbola. So when I take the hyperbola and I rotate it 45 degrees, we get the special case of the rectangular hyperbola, which is the reciprocal of y equals x. And the reciprocal is y equals 1 over x, if you recall from before. I would multiply both sides by x, so therefore I get x times y equal to 1. Or generally, I can say that x times y is equal to k, where k is an integer. So let's take a look at this example, which we've done before, but we've never seen it written this way. So we have x times y equal to 1. Okay. So I'm going to make a table of values. So I'm going to choose some negative numbers, -2, -1. I do want to show you -1/2 as well. And of course we pick 0, and then +1/2, 1, and 2. So if x is -2, in order for us to get 1, y must be -1/2. And then y is going to be -1 if x is -1. If x is -1/2, in order to get 1, our y value has to be -2. Now, if x is 0, that's impossible because we want it to equal 1. So this is where we get our asymptote, and y is undefined. So for half, we get 2, 1, we get 1, and 2, we get 1/2. So graphing this, I'll plot these points on our grid. So 0 is undefined, so I'm going to draw in our asymptote. Half is 2, 1 is 1, 2 is 1/2. So this looks exactly, because it is, like a reciprocal graph. And you can see that it is so because I can rearrange this equation to be y equals 1/x. And our asymptotes here are x equals to 0. And then don't forget we also have a horizontal asymptote of y equals 0. So this is how you graph the special case rectangular hyperbola.